Is there a way to, if everybody can...
Is this my picture?
If everybody can go on mute, that to make sure, that would be helpful.
Everybody is on mute.
Oh, okay.
Yeah, we're now live on Facebook. I'm going to start the recording and we can start the webinar.
Okay, just tell me when. I'm just writing some of these things down from the chat. All right. All right, guys, welcome to this Trial Site News webinar. With us, we have Dr. Gert van den Bosch, and we're going to try to make this as interactive as possible. So please, the topic that we're focusing on is vaccine mandates, COVID-19 vaccine mandates in children. And so if you can, you'll see the question and answer box. If you have questions, please post them there. I will be looking at that and relaying them to Gert so he can answer them. So let's see, I'm just going to check here. I think that's a great one. I'm going to start with this one that I saw about the clinical trials. Gert, are you ready for this one? You can hear me.
I'm ready
okay?
for all the questions.
You're ready? Okay.
If I understand them, I should be able to answer them.
Okay, so this one is regarding vaccines for children and how they're not addressing in any way potential side effects. One person here writes that they said the phase one, 2, and 3, the phases of those trials will overlap. That means that the process might have been sped up, and they feel that they might not be safe. Can you address that?
Yeah, well, as everybody knows, I've not been taking a deep dive in side effects for the simple reason that it is just unthinkable to vaccinate children and even youngsters. The impact thereof is just going to be dramatic. And I can tell you that the side effects and everything that could possibly be observed as an adverse event by vaccinating children is almost nothing compared to the damage that we are going to do by vaccinating the full children population. So I'm really afraid that the discussion about this whole mass vaccination is still about the side effects. I mean, of course, I can understand this, and this is very important, but we should not allow to get our kids vaccinated in the first place. That is the key message. I mean, that is so important. Under no circumstances, really under no circumstances, should children and young people be vaccinated. Because if we do this, this is literally going to lead to a disaster. It's not going to help us to generate herd immunity. In contrast, on the contrary, it's just preventing the population from getting herd immunity. So I'm not sure I agree with this kind of feeling. Well, you know, if I think we let our kids vaccinate, then at least the vaccine should be safe. Under the condition that the vaccine is safe, okay, we can maybe allow vaccination in children. We can maybe deal with vaccine mandates in children. We cannot. We can, under no circumstance, deal with vaccination in children. And there is clear, and this is purely based on science. And we will see to what extent we will come to the science. But it's very, very clear that vaccination, especially of age groups lower than 40 years, is having a dramatic impact on the evolution of this pandemic. And if we don't stop this, if we go on with this, there is no doubt whatsoever, scientifically speaking, that this will lead to a disaster. So I don't know, within that context, whether I should still address to what extent any clinical study has been addressing side effects in children. for me, it's irrelevant. It's a no-brainer that we cannot vaccinate children under no circumstances. And that's what the science tells. And maybe we will see to what extent we come to the science that makes me that makes me make such strong statement, right?
This question, Dr. Van den Bosch, is from Pat in California. And they say their governor has mandated vaccines for all kids K through 12. I am of the Over My Dead Body group. The key is the mandates are only when the vaccine is approved. Do you think that the vaccine will be approved for children?
My fear is yes. And let's be very clear about this. I mean, over the last 6 months or over the last 12 months, we have seen that there is a number of people, the majority actually, not necessarily of laymen, but certainly of health authorities and politicians and governments that are so convinced that this pandemic is going to be solved by mass vaccination. On the other hand, we have plenty of experts, many of them are not allowed to speak or are censored, but that are completely convinced that this is the worst thing ever we could do, mass vaccination against this type of virus. So this in its own right already illustrates that something is wrong. How can that be that to what extent intelligent people are so convinced that this is the right thing to do and others are saying this is absolutely wrong? There is only one explanation for this. The only explanation why we are having this crisis and this chaos currently, there's only one explanation, and it's very simple. The pandemic is not understood. And that is the biggest issue actually. Even the health experts, etc., don't understand the pandemic. They don't understand the evolutionary dynamics of this pandemic. They don't understand the repercussions of, for example, vaccinating children, youngsters, etc. And because, unfortunately, these people don't want to engage into purely scientific discussions with people like me and others, they continue to, in fact, advise the governments and the politicians. And of course, the politicians, they are convinced that this is the right thing to do, and they have the mandate to do this. They have a mandate. I'm always saying you combine this illiteracy, scientific illiteracy, and a political mandate, and you prepare for a disaster, basically. So yes, my fear is that if people themselves become not aware of the repercussions of these mass vaccination campaigns, and we leave it up to the politicians and to health experts, that yes, you can imagine everything. You can even imagine that there will be vaccine mandates for babies, right? I mean, it's as crazy as that. So that is the reason, I guess, why we are doing this. I mean, if we cannot have an open scientific debate, and if lawsuits are just like, fighting one case against another, where snapshots are compared, one snapshot against the other, what else can we do to raise people's awareness? It's just to inform them and to clearly explain as clearly as possible why this is so disastrous to vaccinate, according to my opinion and my conviction, all healthy people, right? But especially, as I was saying, the age groups below 40, because it can be clearly shown, these are pure data, that the repercussions of vaccinating these people, of taking away their innate immunity and replacing it by an adaptive immunity that is not capable of limiting the spread of the virus, because it does not induce sterilizing immunity. We have been discussing this over and over again. Vaccines don't do this. Well, this is, of course, a disaster, because by doing this, you put the virus under more and more pressure, and you will have resistance. We are coming close to that, right? And that helps nobody. So
Dr.
yes,
Van den Bosch,
my fear is yes. they may decide to go ahead and to impose all these mandates.
A lot of questions are referring to your commentary on the repercussions. You're saying that that's more important than the side effects of the vaccine, which we're focused on. Can you maybe provide a general overview about what it is you are most concerned with?
Well, what I'm most concerned with is, as I was saying, but I will explain a little bit more in detail, the fact that the evolution of this pandemic is not understood. And what I mean with this is that we were just talking about clinical trials, right? Where you study, of course, the impact of a vaccine in a well-defined setting where parameters are very well defined, etc. So, as we all know, the vaccine efficacy is always the result of the interplay between the immune system and the pathogen, in this case, the virus. So if you can increase the immunity by vaccination, you would think, indeed, we are better armed to fight the pathogen, the virus, and so the vaccine efficacy will be okay. And this was indeed the case in those studies. Now, what we forget, and here comes the aspect of the mass vaccination. I'm not against vaccination, of course, I'm against mass vaccination, is that if you are now going to massively vaccinate people in the midst of a pandemic, so you cannot diminish the spread of the virus, or you can maybe diminish it, but not sufficiently. And in the meantime, you exert tremendous pressure on that virus. Well, in fact, the population that gets vaccinated, because all these people are going to mount antibodies. What you're going to do is that you are inevitably going to select for mutants. So, of course, the virus is mutating all the time, no problem. The only thing is when you now put the virus under immune pressure, that it will become difficult for the virus to replicate. So it will start to select, it's in fact the immune system that does that, to select the more infectious mutants, the more infectious variants that are still capable of coping with this increased immune response. And if you do this now massively in people, when the virus jumps from one person to the other, it will, every single time, it will find itself into this competitive environment, into an environment where it has a fitness advantage, a competitive advantage, because of its immune pressure, where other less infectious viruses cannot replicate. So why I'm saying this? Because ultimately, this leads not, of course, to the emergence of more infectious variants. We had them already before the mass vaccination campaign started, but it leads to an enhanced propagation of more infectious variants. And we have seen indeed that since the mass vaccination campaign started, the propagation, the expansion in prevalence of the more infectious variants have just exploded. Okay, so what does that mean? That means that all of a sudden, you are now going to increase the infectious pressure in the population. So in other words, you are no longer dealing with the same virus that what was tested in the clinical trials. You're dealing with viruses that are much more infectious and that are increasing the infectious pressure. So what does that mean? Well, that means that this will also have an effect on your placebo. So in the clinical trial, the placebo is the non-vaccinated person, right? Is the unvaccinated person. So do we think that this enhanced propagation of more infectious variants in the population is now all of a sudden not going to affect the unvaccinated? Of course it will. The unvaccinated can develop asymptomatic infection, or they can develop even symptomatic infection. But in any case, they will develop also an immune response against those viruses or against the virus. So we are no longer dealing, in fact, with a non-vaccinated placebo was not seeing the virus. Remember, this was an exclusion criteria for the clinical trials when you got previously, for example, infected and you got the disease. So this means that the whole dynamics, the whole interplay between the virus and the immune system taken at the population level is changing, because you change now the infectious pressure, you also change the immune response of in fact the population. And as I was saying, I'm primarily concerned, and now we come to the children and the younger people, about one phenomenon that has been documented in a number of references from the literature, which is what happens to people who got asymptomatically infected. So during the circulation of, during the pandemic, people who develop asymptomatic infection, they very often develop antibodies. They develop antibodies, and Erin, I don't know whether we need to show it right now, but we have a slide on this.
I was gonna, I didn't want to interrupt you, but yes, I'm gonna share the screen. And here we go. Okay. Let's see.
No, it's the last one, or the one before the last one. No, not this one, the one before, I think.
Okay, wait, let me just go.
Well, it's not that in.
Hold on one second. Let me just do this again, because I think.
Yeah, otherwise I can explain. It's not extremely critical.
Okay, let me find it. All right, let me work on this, Gerpa. Keep going.
Well, yeah. Well, all I wanted to say is when people are asymptomatically infected, they develop antibodies against the spike protein, but these antibodies are only short-lived. They last for about 6 to 8 weeks. After 8 weeks, they are not detectable. And the graph that Erin was looking for is just showing that in asymptomatically infected people, after 8 weeks, these antibodies are completely gone. So these antibodies are short-lived, as I was saying, and they are not really mature. And by the way, these people do not develop B-cell memory. They do not develop memory cells because the immune system has not been thoroughly primed. But what these antibodies can do is that they can nevertheless protect against the disease, but they will not be able to protect against infection. And because their affinity for the virus, is bigger, more important than the affinity of the innate antibodies, these specific antibodies, short-lived antibodies, will outcompete the innate antibodies. So let me just talk 2 seconds about innate antibodies. Innate antibodies are, for this disease, incredibly important. Why am I saying this, and what's the proof for this? Well, everybody knows that when the Wuhan strain came in, when the pandemic started, in other words, I mean, the vast majority of the population, certainly all healthy people, especially, of course, youngsters, but in fact, all healthy people, did not even show any symptoms, right? Come on, how can that be? We have never seen the virus, so there is no acquired immunity. And the virus was definitely circulating, and pretty fast, because it became a pandemic within a few weeks. So is there anything else that could have protected us? Well, the answer is, of course, innate antibodies, right? And these innate antibodies, they are fantastic in a sense that they are not variant specific. So they can in fact deal with all kinds of different coronaviruses. So despite that, we see that now all of a sudden, the very same people, the very same youngsters, the very same healthy people that didn't even show symptoms back half a year ago or a year ago, now all of a sudden are developing symptoms, and they get a disease. And how can this be explained? This can be explained, in fact, by the fact that, and there is at least 2 or 3 papers that document this, that the antibodies that people develop as a result of an asymptomatic infection, they can, to some extent, outcompete the innate antibodies. The innate antibodies that are so important because these innate antibodies, they provide sterilizing immunity. So that means that these antibodies, they can neutralize the virus, or they can most likely, in synergy with natural killer cells, eliminate virus-infected cells at a very, very early stage in the disease. So this innate immunity is, of course, incredibly important because it induces sterilizing immunity. So that is also the reason, and young children have a lot of these innate antibodies. It's also the reason why, for God's sake, this is not a childhood disease. This is not a childhood disease. Initially, as I was saying, no children got disease. Yeah, there's always a few exceptions, genetic deficiencies, or children with underlying diseases, etc. But at large, there was no problems in this age group. So this is not a childhood disease. So, but now people could say, yeah, it is a childhood disease because look, there is now younger people, or maybe not childhood, but younger people getting the disease. Of course, because they got asymptomatically infected previously, developed short-lived antibodies, and these short-lived antibodies, they can outcompete. You can see it here. I don't know whether people can see the cursor, my cursor. This is an innate antibody.
Am I the right?
I'm pointing to it, to this multimeric antibody. And so this is the IgM, but it's not an adaptive IgM, it's an innate IgM, but forget about it. Innate antibody versus a specific antibody. And this is the virus. So the antigen-specific antibody has higher affinity, it can outcompete the innate antibodies. So that is, of course, not good because the innate antibody can provide sterilizing immunity, whereas I was just saying the antigen-specific antibody that results from asymptomatic infection has low affinity. It can only protect against the pathogenicity, against the disease, but it cannot protect against infection. And so what the consequence of this is that, of course, we get more infectious strains. And these more infectious strains, what they do is that they will increase the likelihood that somebody gets exposed to the virus. So in other words, if you have a highly infectious strain circulating in the population, for example, right now, the Delta, the likelihood that you are going to become infected with that Delta variant is relatively high. It is higher than the likelihood that existed for exposure to, for example, the Wuhan strain initially. Okay, so now what happens to these people who got already infected, who got previously asymptomatic infected and are sitting on antibodies that last for about 6 or 8 weeks, but that can outcompete their innate antibodies? Well, when the Delta variant is now circulating, as I was saying, the risk of exposure becomes higher. So the risk that somebody who is still sitting on this immune suppressive antibodies will get reinfected with the virus becomes now much higher. So the likelihood that somebody now becomes infected shortly after having been affected previously becomes increasingly higher. So that means that the likelihood that people who got previously infected will now become susceptible to the infection and the disease becomes much higher because their innate antibodies are outcompeted. And that explains why we are now having more and more people, young people, who get infected while their innate antibodies are suppressed. And of course, if you then look at the curves, you will see the following. Well, maybe, Erin, we can put up the first slide and the first one, yeah, number 2, yeah. Okay. If you now look, for example, at on the left panel, figure 2, the left panel A, you see that in the younger age group, so this is from Public Health England, they do these surveys weekly and monthly. So this is vaccination status week 31 to 41. And what you see is that in the younger age group, so look under 40, for example, you see that, wow, the vaccine is capable of controlling the infection, whereas in the unvaccinated, that's not the case. So my conclusion, come on, let's vaccinate younger people, let's vaccinate the kids, which is completely wrong. It's completely wrong. Why? Well, because people don't understand these curves. They don't understand what this means. All the public health authorities are looking at curves and at tables like, somebody who is following the stock market is looking at the evolution of a currency. This is very, very bizarre. Look at the black bars from left to right, they go up and then they go down. And the gray bars, they from left to right, they continue to go down. So what is happening here? Why all of a sudden does the vaccine seem to control viral infection in younger people? And health authorities say, wow, if we want to have an impact on the transmission, we need to vaccinate these people. And this is completely wrong. What is happening here is the following. So we know, of course, Delta is circulating. I was saying the likelihood of being exposed after having been shortly after having been exposed previously becomes higher. So many of these young people are still having short-lived antibodies. They are directed against S protein, against spike protein. Okay. So if now on top you're vaccinating them, well, the vaccinal antibodies are also directed against S protein. So you get a tremendous synergy between those antibodies, the short-lived antibodies that people are still sitting on, and the vaccinal antibodies that they acquired, of course, thanks to the vaccine. And so you see a tremendous impact, an overestimation, in fact, of the vaccine effect. Whereas in the people who did not get vaccinated, as I was saying, they are sitting on these antibodies that outcompete their innate antibodies. So the innate antibodies cannot do anything. They are not destroyed. Some people say, I'm saying that they are destroyed. No, they are not destroyed. They are just bypassed, right? They are no longer functional because they're outcompeted. So, but on the other hand, if you look the curve below, Erin, if you could just take the next curve, the next slide, please. Yeah, for the same age groups. We are not there yet. Okay, that's it. So you see, for the same age groups on the left, under the age of 40, this is hospitalization and disease rates. Hospitalization and disease rate is very low. So that means that in the unvaccinated, despite the fact that they cannot control infection, these short-lived antibodies still, to a large extent, protect them from the disease, right? And so that is an interesting observation, because if that is, and now we go again to the first slide. In older people, we need to go to the previous one, because now I wanted to talk about comparing this to the older age groups. And
this slide, or you need the next one?
I need the first one. The first one. Okay. Yeah. The first one, just to, yeah.
Okay.
Okay, we have been looking at the age groups below 40, where basically the vaccine did a better job than natural immunity, so to say. If you now look at the right, the right part of the curve, you see exactly the opposite. There, the unvaccinated except for people maybe above the age of or of 80, but are doing, but the unvaccinated are doing better than the vaccinated. So what does that mean? Well, this can be explained by trained immunity. The older people get, well, older people have been more and more antigen experienced, and their innate immunity got better and better trained. And there is papers that indicate this, that due to epigenetic changes, and that is due to environmental contact with several different stimuli, to some extent from the microbiome, etc. The innate antibodies, they acquire a higher affinity for the virus, for example. And so that means that they are less easily outcompeted. So the more the innate immunity get trained, for example, in these older people, the better they can, because they are no longer completely outcompeted, the better this person can deal with the infection. And you see that the infection rates are going down. So what we learn from this is that, oh, the more you get exposed, in fact, the more your immune system get trained, your innate immune system get trained, the better you can deal with this virus. Of course, this does not apply to all the people. These are just people, remember, that got the infection, but without symptoms. These are just the cases. So these are the asymptomatic infections. Because if you now would go to, again, the following slide and look at the hospitalization rate for these older age groups, you will see that there, of course, there is, they go up. Why do they go up? Because, is this the next slide? Yeah, in the unvaccinated, you see how the hospitalization rates go up, because of course, in these older age groups, there is a number of people who have very poor trained innate immunity. Why is this? Because of underlying diseases, because of unhealthy lifestyle, all these type of things. And so this means that, and also the age in its own right, that to a large extent, in these older age groups, the trained innate immunity cannot deal with the virus. It's not sufficiently trained, it's weakened. Therefore, already take home message, the major message here, or the major conclusion for the older age groups is keep your innate immunity trained. This is the best defense ever against the virus. But what this tells, and that is the point I wanted to come to, is that the more your innate immunity gets trained, the less it will be outcompeted, and the more it will be effective in dealing with the infection and lowering the viral infection. And so if that is true, we would expect that, for example, a number of weeks later, we see, when we now look again at the previous graph, where we saw that the infection rate for the age groups under 40 was pretty high. If that is true, that the innate immunity can be trained, and we would expect that a number of weeks later, where also these people got increased and frequent contact with the virus, that they're trained, that their innate immunity get better and better trained. And if that is true, you would then expect that the innate antibodies can no longer be easily outcompeted, and that they are become, in the unvaccinated, become very efficacious in fighting the infection. So if we look indeed what is happening, because this was week 38 to 41, if you now look at the next slide, about 1 month thereafter, yeah, no, sorry, Erin, that's my fault. It's the first graph, but it's the right instead of the left part. Yeah, if you look at the right part of the slide, what do we see? We see indeed that in the age groups, 2 of the age groups, the second and the third columns, the infectious pressure in the unvaccinated has gone dramatically down. This can only be explained by enhanced contact better training. These people are already older, and their innate immunity got already to some extent trained. It can be trained even better because of frequent contact. We have been opening up society. There is Delta variant circulating, so they're all the time in contact with the virus. So their innate immunity got much better trained. In the very young, including the children under 18, this immunity is so immature, it got not sufficiently trained. But I can tell you, if we are going to get back to these curves in a number of weeks from now, you will see that this also for the lower age group, the bar, the gray bar will go down because they got better and better trained, and they will be able, the unvaccinated, to deal with the infectious pressure or with the infection without vaccination, because you see already that the difference, of course, now between for the age groups 18-29 and 30-39, that now it is the unvaccinated that are more efficacious, in fact, in reducing the infection than in the vaccinated. So, in other words, what this means is that if we are now going to vaccinate the children, we take away this very, very important arm of the innate immunity, because here we could say, well, the vaccine is having a positive effect because it reduces the infection. But if that is something that is fine and great as long as the vaccinal antibodies work. And I guess what I'm saying, and what is for me 100% true, is that we will have, by putting the full population under this type of immune pressure without reducing the infectious pressure, we will ultimately have resistance to the vaccine, virus resistance to the vaccine. When that happens, the vaccinal antibodies, they become useless. They become useless in the sense that they don't protect you anymore, but they will still be sufficiently binding to the virus to outcompete the innate antibodies. And so if these antibodies, the vaccinal antibodies, are no longer efficient and your innate antibodies are outcompeted, you're almost left without any immunity. So now you could say, what is the difference with the unvaccinated? Well, the unvaccinated, as I was saying, they're also under immune pressure, but the immune pressure comes from the short-lived antibodies. These are the short-lived antibodies that they are getting from a previous infection. And these short-lived antibodies, they will, of course, to some extent, protect them against the disease. But what will happen is that the more their innate immunity gets trained, the more these unvaccinated people will be able to deal with the infection and will bring down the infectivity. We have just seen it already after a few weeks, how the infection rate goes down thanks to training of the innate immunity in these people. So now we start to have a situation for the first time, and that is why we cannot vaccinate the children. We start to have a situation where the infectious pressure goes down. Why? Because first of all, the trained innate immunity is now capable of coming back. It is no longer fully outcompeted by the short-lived antibodies. So it's coming back, and it can start to clean up the mess. It can, I call them very often, the sponges or the vacuum cleaners, right? These unvaccinated young people, because they can start to eliminate the virus. The infectious pressure goes down. What happens when the infectious pressure goes down? Well, when the infectious pressure goes down, the likelihood that somebody who got previously vaccinated, who got previously infected, asymptomatically, gets reinfected within 6 or 8 weeks becomes now very low. So that means that the likelihood that the innate antibodies will become outcompeted becomes lower and lower. So in other words, now the children, they can again fully exploit their innate immunity to completely eliminate the virus, because this is sterilizing immunity, right? That is something that can never, ever happen with vaccinal antibodies. As I was saying, vaccinal antibodies will lose their functionality and they will continue to suppress the innate antibodies. Why is this? Because the vaccinal antibodies, they got strongly primed in contrast to the antibodies that result from a previous asymptomatic infection. They are short-lived, they're immature. Immune system got not really primed. So there is a decay. They disappear after 6 to 8 weeks, which is fantastic if the infectious pressure goes down, because then the probability to get reinfected within 6 or 8 weeks is low. And so you regain your full capacity of your innate immunity. That is never going to happen with the vaccinal antibodies, because the virus continues to circulate. And remember, every single time you have contact with the virus again, your primed vaccinal immunity, vaccine-mediated immunity, will go up again and will be high for the next 6 or 8 months. That is what folks are now trying to do with all these boosters, is to boost these vaccinal antibodies, right? The problem is you derive the virus. We are not going to vaccinate ourselves out of this pandemic. No, on the contrary, we are going to vaccinate ourselves into resistance to the virus, to the vaccines, but the innate immunity will remain suppressed. So your vaccinal antibodies are not worth anything, but they still will suppress the vacuum cleaners of the population, which is the innate immune response in especially the young people and youngsters all together. I know this is very difficult to understand. I know that many people will not understand this, but the basic or the bottom line is really that if we continue, or if we even touch upon our children, and in fact, all people below 40, there you will see their innate immunity got not trained optimally. That's in those curves, in those graphs, you see the biggest impact of training you see in those age groups. They can really make a big change. You train them, they make a big change. These high gray bars, they go down dramatically. Whereas in the older people, trained immunity is important. You need to keep it up. But of course, their capacity of training is no longer the same as in young people. So first of all, vaccinating children means automatically that these children will be fed up with an immunity that will not serve them for much longer, because the resistance to the vaccine will come. There is no doubt about this. And if you look in all the publications of molecular epidemiologists, you see the kind of activity in the S1 protein that is all in fact driving to more resistance to the neutralizing antibodies.
Dr.
That is one
Vandenbosch,
thing. Yeah,
can we have so many questions here. So
I understand.
can we I want to, there's so many, I just want to make sure we cover as many as we can. This one is a good one from Brenda. She writes, one would think the pediatric medical community understands vaccination in children, or the threat of vaccination in children, yet many people support the vaccination of children. It's some would call it maybe a scientific consensus in certain groups. How would you respond to that?
Well, my response is simply what I told before, that doing vaccinations in a pandemic, during a pandemic, a completely different context, is not understood. Of course, the pediatricians understand prophylactic vaccination, where you just vaccinate a segment of the population outside of a pandemic, even outside of an epidemic, and you make sure that, for example, these children have full-fledged immunity before they are, for example, exposed to the virus, right? So here we are dealing with a completely different situation where we do the vaccination during the pandemic. This is one thing. And then second, most importantly, and this is just unbelievable, this disease, as it started, was not a childhood disease, right? This is typically a disease of elderly people, people with underlying diseases, people who are immune suppressed, etc. So, in other words, if we would do the same thing with influenza, right? Influenza is not a childhood disease. It's a disease, again, of people, elderly people, immune suppressed underlying diseases, right? If we would now have a pandemic of influenza and we would massively vaccinate the whole population, we would have exactly the same problem. So the fact, to the question, that it's not even understood that this is not a childhood disease, and that the question is not even asked, what is it then that in this disease, for this disease protects the children, and that there is no knowledge about innate antibodies. On my website, there's at least 7, 8 publications on innate antibodies, and it is acknowledged that it is not part of mainstream immunology, not part of mainstream vaccinology, that it is considered contradictory because, same when you talk about natural killer cells, people say, well, oh yeah, the role that is not clear. But here we see these youngsters, these children are protected, naturally protected by innate antibodies. So it is a complete misunderstanding. This is different from a disease, for example, like measles, which is highly infectious. It will go straight through your innate immune defense. So there you cannot rely on innate immunity. It will get, the infectious pressure is so high that it will go straight through the innate immunity. You have no other chance than to vaccinate, but you would never vaccinate the whole population. You will vaccinate the children. These are our childhood vaccines, right? So this is a completely different situation. This disease is completely misunderstood. And what I'm saying is always lacking. The element or the field or the discipline that is not understood is immunology. If there is, of course, you draw to understand a pandemic, you draw from vaccinology, from virology, from evolutionary biology, and from immunology. But what's definitely not understood is immunology. So we think we can simply, immunity is complex. I've been talking about 4 types of immunity. Innate immunity, right? You have, of course, the acquired immunity. You can acquire this through vaccination, or you can acquire this through natural disease, which is not the same. And I've even been talking about a kind of mix of both. Asymptomatic infection, where you get some adaptive immunity that is outcompeting innate immunity. So guess what? We think, we don't need to bother about all this stuff. We just, replace all this by vaccinal antibodies, and that will do the job. Not realizing that we are in a very dramatic way eroding the innate immunity in youngsters, and the innate immunity is the only immunity that is providing sterilizing immunity. And we all know this is critical because a pandemic is very, very simple. A pandemic is controlling a pandemic is very, very simple. It's all about controlling transmission, controlling infection. If you have no control of infection, you're never, ever going to control a pandemic. And what do we see? What do we see with this pandemic? You see that the infectious pressure goes up. Look in all the countries that have been mass vaccinating very aggressively. The US, Israel, the UK, they did very aggressive vaccination, right? You will see that the baseline of infection, if you look at the world in data, you look at the curves, simply the cases, you will see that you have, of course, waves, etc., but you're dancing on a baseline of infectivity that is now way higher than back half a year ago or a year ago. So that means that the infectious pressure is increasing. That's exactly the opposite of what you should be targeting with an intervention in a pandemic. You want to bring the infectious pressure down. If you do not succeed in bringing that down, you will never, ever solve the pandemic, because the only solution for a pandemic, really the only solution, is herd immunity.
Thank you.
That means diminishing transmission.
Okay, I just want to remind the participants to upvote the questions in the Q&A box so we can ask the questions that people are most interested in. Dr. Van den Bosch, I'm going to read you one from John. There is an argument that virus can't escape vaccine spike targeting mechanism because in order for the virus spike to mutate enough to escape the vaccine's targeting, the virus spike would have to mutate so much that it would no longer be functional, and the virus would lose its ability to infect. Is this an incorrect argument?
Yeah, I would not understand why the virus would no longer function. You would never, in fact, the phenomenon of immune escape is based on natural immune selection. So that means that you will have all the time mutants, all kinds of mutants, and the one that is capable of overcoming the immune pressure will survive and will replicate and will propagate. So do we think there is a number of limitations in the changes that a virus can propose? So, I mean, there is thousands of mutants, and the one that is fittest and can overcome the pressure will survive. And then people start analyzing all these epitopes in the receptor binding domain, and they say, oh, wow, now we have approximately, tried everything, and we can target all these epitopes, and then we should have, for example, a vaccine that is completely functional. But they forget that even a mutation in a distant domain, like in the N-terminal domain, can all of a sudden induce a conformational change of this receptor binding domain, and guess what? The neutralizing antibodies don't bind anymore. So this will not prevent the virus from surviving. So what I'm saying basically is that a minor change, it does not need to be an accumulation of all kinds of changes. A minor change that bypasses the receptor binding domain, for example, that in a way that antibodies could no longer bind. Of course, it should still be able to dock on the receptor, but that antibodies cannot no longer bind. It will provide the virus with a competitive advantage without having any functional impact, because if it had a functional impact, it would not have been selected in the first place, right? So
okay, thank you for that. This question with 7 upvotes from Gregory. Could you please expound on the concept of antigenic sin in the context of the current vaccinations and how it impacts a vaccinee's immune response to current and future coronavirus pathogens? Yeah,
well, first of all, if we talk about antigenic sin, I think we are alluding already to the boosters, right? I had hoped at least, well, it wouldn't have changed my mind or my opinion, but we are now learning that the boosts are, the vaccine used for the boost is exactly the same as the one we used for the first 2 doses, right? I mean, everybody was initially thinking they are going to reshape this vaccine to better match the circulating highly infectious variant, which is the Delta one. But that hasn't even happened. So antigenic sin means if you now are going to vaccinate again, even with a vaccine that would be different. Let's assume that in the next round, they put the S protein that corresponds to the Delta variant in the vaccine. Well, even then, you could say, wow, this now matches the circulating variant, this is going to help. No. Why not? First of all, what is going to happen, and that is antigenic sin, is that when you vaccinate those people, even with an adapted vaccine that is much better adapted to the circulating variant, what will happen, that's the definition of antigenic sin, is that it will first recall the old antibodies. It will recall the antibodies that were initially generated against, well, I call it the Wuhan vaccine. So that means even if you come back after an immunization, you come back with an antigen that is slightly different from the one you have used to prime initially the subject or the individual, you will still, first of all, recall the old antibodies. And only later on will the new antibodies be primed and start to circulate. But this is pretty dramatic because you could say for influenza, for example, the seasonal vaccination, it's not a problem. Why not? Yeah, of course we have antigenic sin, and if we start vaccinating somebody who got vaccinated last year or 2 years ago, or maybe even 5 years ago, you will recall first these antibodies. So no problem. Why is that not a problem? Because these people are not in a pandemic. You will finish and accomplish your vaccination before the flu season starts. That's the goal, right? You get vaccinated before the flu season starts. By the time these people get exposed to the flu, they will not only have recalled their old antibodies, but they will already have built their new antibodies as well. So they are well armed to attack or to be exposed to the new seasonal flu. When we do this during a pandemic, that means that the old antibodies that will be recalled, they will continue to exert immune pressure on the virus. And so if those old antibodies were not capable of controlling the infection before, so how then would they now be capable of doing so? Just because the titers increased? No, because the detrimental effect of the increase of the titers is that your innate antibodies get suppressed. Remember what I said, right? The vaccinal antibodies, even if they don't work, or even if they work only partially, they will always suppress your innate antibody, and it is the innate immunity that has sterilizing capacity. So antigenic sin is, in other words, even with new and adapted vaccines, the reason why, if we boost, even with the Delta, with the nest protein that would accommodate or that would be adapted to the Delta variant, we will only expedite the resistance. That is my strong conviction. And people can look even now with the same booster and the same in Israel, what is going to happen. These guys think that the curve, the fourth wave, will go down to the baseline. I tell you, these are predictions. People can write it down. It's recorded. There may be a plateau somewhere, right, way above the x-axis, and then it will go up. That is for me very, very clear. You don't control infectious pressure.
All right, thank you. This next question is from Peter. How would the disease profile of antibody-dependent enhancement due to antigenic drift differ in children compared to older individuals if a mass ADE event does occur? Furthermore, you note that a widespread ADE event could potentially occur. What is your confidence or estimated probability for this?
Well, I can only speak in general to ADE. I know it's a heavily debated topic, but basically, to make things simple, for one time I will make things simple. There is a concern for ADE every single time when you have antibodies of low affinity. And so you can check, when do you have antibodies of low affinity? So is there a rule? This is going to happen with this vaccine. This is going to happen in this particular person? No. Every single time you have low affinity antibodies, for example, I was just saying, you get infected, asymptomatically infected, you will develop antibodies, short-lived antibodies, immature antibodies. These are per definition antibodies of low affinity. It's not for nothing that we see in many younger people that are now getting the disease, who got previously protected, that the disease is even enhanced. When they get infected and exposed during that very time where they are sitting on these low affinity antibodies that last for about 6 to 8 weeks after previous asymptomatic infection, they could theoretically be subject to ADE. Another situation is, of course, what we do right now. We have variants that are very, very different right now, the S protein, from the Wuhan strain. So when we vaccinate still with the Wuhan strain, that means that with regard to the target spike protein of the Delta variant, these antibodies have relatively low affinity. So they don't recognize the S protein of the Delta variant very well. And what can happen is, especially when these antibodies are at low concentration and still low affinity, for example, after the first vaccination, that you will raise antibodies that have low affinity. First of all, because it was the first injection, these people still expect to have a second one, boost. So after the first injection, antibodies still need to mature. And secondly, they don't recognize the S protein of the circulating variant very well, because that's the Delta and you got vaccinated with the Wuhan. So these two reasons, for example, the combination of both makes often people right now after the first vaccination susceptible to antibody-dependent enhancement. So every single time you are dealing with antibodies that don't do their job really very well, what they are exposed to do, namely to neutralize the virus, you can have this this problem.
Thank you. So this question is from Anonymous, and I want to try to state this the right way. This is a new development in the UK vaccine surveillance. They want to get an understanding of this statement in the latest UK government vaccine surveillance report. N antibody levels appear to be lower in people who acquire infection following 2 doses of vaccination. Does that, there's a link to
people
okay,
who received 2 doses of vaccination.
yes, and this is in quotes.
I mean, is this saying that the boost is lowering, in fact, the antibody titer instead of increasing it?
I believe that is what this is saying. N antibody levels appear to be lower in people who acquire infection following 2 doses of vaccination.
Oh, who acquire infection. Well, what you can always have, because it works also the other way around. Let's assume you get first vaccinated, for example. If that is the question, you get your 2 doses, so you mount a reasonable amount of antibodies and substantial antibody titers. Of course, if these titers are sufficient to well neutralize the virus that comes in, the wild virus, when you get exposed, then the antigenic stimulus will be diminished because the virus got neutralized before it got to really re-stimulate the immune system. The other way around would work as well. Let's assume you got the natural infection and you cure out the disease. So you get acquired antibodies, high levels of acquired antibodies. If shortly thereafter you get vaccinated, you could imagine that the S protein gets completely neutralized by the neutralizing antibodies that got induced by this naturally acquired infection. And therefore, we call this in vaccinology, you don't have a vaccine take. So the immune system has not really seen your S protein because it got really neutralized by the still existing, pre-existing neutralizing antibodies before it got an opportunity to stimulate the immune system. So in that way, you could understand that if you have a priming, be it by vaccination, be it by natural disease, natural infection, and you have you stimulate the immune system again with the same antigen, that the antibody response may be diminished because you don't have a take of the antigen. It got neutralized by the still existing antibodies, for example. I don't know whether this is an answer to the question, but it's to the best of my knowledge.
It sounded pretty good to me. Okay, this is another question from anonymous attendee. Could you please, in simple words, describe what an immune escape means for the society, people personally, in simple terms?
Well, first of all, we need to ban the word personally and individually. I would like to expand a little bit on that, because it's only by solving the problem at the population level that every single individual will have an advantage. If we look for the individual advantage, we will never ever solve the problem, because the individual advantage is looking how can I protect myself against disease, for example, right? I told you before, the pandemic, solving the pandemic is not about reducing hospitalizations and death to begin with. It is to control the infection. And as a result of the control of the infection, you can then have a positive effect individually. So that means you can only control the infection if you have herd immunity. That is a population effect. And we will all benefit from this. If from an individual benefit, you will never generate herd immunity. So we need to stop these discussions, look at individual levels. I know it's very, very difficult, but this is something that plays at the population level. Only when we succeed as a population to diminish the infectious pressure will we have a positive impact for all individuals. So now with regard to immune escape, well, that's exactly what I'm saying. You cannot avoid immune escape on an individual basis. Immune escape happens, as I was saying, all the time. If you have antibodies, you get infected by a virus that has high mutability, like this coronavirus, for example, then automatically immune escape variants, so that means mutants that can escape to the immunity that you mounted, the response that you mounted, will be selected. Okay, who cares? Who cares? Because if that virus is now transmitted to somebody else who got not vaccinated, for example, and who has his innate immunity, this virus will be eliminated. It doesn't matter whether it's more infectious or less infectious. Why? Because innate immunity does not discriminate against more infectious virus or less infectious virus. It does not discriminate. That is why you will never have, with innate immunity, this kind of immune escape. But if now the immune escape variant that was selected in your body is now transferred to somebody else's body who is also in the same situation, having mounted an immune response that exerts pressure on the virus, so that again, the variant that was selected in your body gains a fitness advantage, a competitive advantage, and then again in the next person and in the next person, then all of a sudden your immune escape variant will now become dominant in the population. And that is the word. The prevalence of this selected variant will become dominant. And that is how the infectious pressure in the population increases. And that is where the younger population, based on the mechanism that I explained, becomes vulnerable, right? And that is what explains now why we have so many younger people that are who are getting the disease, basically.
Okay, great. This next question with 7 upvotes from an anonymous attendee. It's very hard to oppose vaccination. As 18 years old, even my parents are forcing me to take the jab. Otherwise, I will require to test myself every third day, which I cannot afford. What do you think are the best arguments against vaccination in young adults? And I think maybe this person is referring something that she or he can discuss with their parents.
Well, my argument, I mean, it's sad to say, but I must say this because this is based on the science. Under no circumstances should healthy youngsters be vaccinated. This is not a childhood disease. When you vaccinate, you will erode the innate immunity. You will pay a price for this, but also if we do this with whole populations, we will never ever have herd immunity. And don't misunderstand me when I'm saying pay price. I'm not making fun of the vaccination, not at all. We need to help each other. So what will be necessary and very important for many vaccinees, it's not the topic of this discussion, I know, but it's of course treatment. It's of course early treatment. If you can, somebody who has lost his or her immune defense, you can prevent this person from severe disease. So this person gets the disease, but you can treat this person. So this person is now capable of mounting an immune response against this resistant variant, right? And that will contribute, of course, to herd immunity. So it's not that the resistant variant, you cannot build immunity towards it. You need to get infected. You need to get a disease so that your immune system gets primed. The risk is if you have no immune defense that you could die from that infection, but not if we treat these people. If we treat these people, they can prevent severe disease. But having gone through the disease, they can, of course, build acquired immunity and contribute to herd immunity. So is there any trick? Is there any way to tell people, well, you can still get the vaccine and, don't care because we will do that, this or that afterwards? No, it's just so misunderstood, as I told you, as I showed there, based on the curves that I showed you, where you now see that the effect of the vaccine with regard to diminishing infection is quite spectacular. And as authorities are not understanding the pandemic, of course, if you just look at this, not understanding what's going on, you say, oh, wow, we need to vaccinate the younger people because that is going to have an impact on transmission, not just going to erode their immunity, right? Their innate immunity. So I'm afraid I have no solution. What else can I tell them? Don't vaccinate people who are in, because on top you see, as I've shown, you have seen these curves that I showed. In the younger people, the more their innate immunity gets trained, the more dramatically they reduce the infectivity without paying a price. Because if you look at the hospitalization and even mortality curves of these people, they are very, very low. They're very low. So they can train their immunity and they can dramatically diminish the infection rate, provided they're not vaccinated, without paying a price, right? And if they would get severely ill or even seriously ill, we need, of course, to treat them. That's very logical.
I just wanted to clarify something. You talked about healthy children. What about kids with underlying conditions or kids who have obesity? Obesity is a problem at younger and younger ages, and we know that's a risk factor.
Yeah, very simple. No vaccination. Scientific explanation. What do you have in these people? You have immune suppression, right? You have immune suppression. Will that help? Will that favor or will that disfavor immune escape? The answer is very clear. The more immune suppression you have, I gave you the example of people who got asymptomatically infected. They develop short-lived immature antibodies. this is this is incomplete immunity. This is suppressing, for example, your innate antibodies. Every situation where you have suboptimal immunity, and that can even be upon infection of these people, be prolonged. So does that mean that these people, we should not bother about them? Again, the same thing. You have to treat these people at an early stage. And I mean, people can be opposed. I'm not in that field. It's not my field of expertise. I'm, of course, following this. But I tell you, sooner or later, and it will be probably sooner, there will be no way around treatment, right? Because otherwise, I don't see how you can save the lives of people who are severely immune suppressed, be it by underlying diseases, being by being vaccinated and boosted, etc. Right? So the question is, we need to treat. The answer is we need to treat them, but not to vaccinate.
This next question, with lots of upvotes from Pat, the director of the CDC has come out saying that the definition of vaccinated will be changed when the booster is rolled out. In other words, anyone without a booster will be considered unvaccinated. This will skew the data. Is there any data we can rely on? VAERS is unreliable.
Well, I mean, this is a topic I would say for people like Steve Kirsch, etc. I mean, of course, everything depends on the criteria. And if people say, for example, well, we consider only somebody who got, who got vaccinated, we only qualify people as being vaccinated as of 2 weeks at least after the second shot, right? This is also with regard to some extent to safety. I told you, when you get adverse events, it's very often early after the first or the second shot, when the antibodies are not yet fully matured, for example. So you can change these definitions, but what worries me, of course, is when the definition of a vaccine gets changed, because now it gets changed in terms of, okay, a vaccine is something that protects you, right? Protects against disease. Again, what I'm saying is that no stuff that protects only against disease is going to solve the pandemic. You need immune interventions that can dramatically diminish the transmission in a population. Without that, you have no effect on the pandemic. And by changing all those definitions, I feel like we are now just trying to prevent hospitalizations and deaths in the very short term, because the picture will, of course, change as the pandemic is evolving. And these criteria, measuring the number of hospitalizations and deaths, is the completely wrong metric for monitoring the evolution and the control of a pandemic. Everybody can follow the evolution of the pandemic. It's so simple. You just look at the baseline of the infectious pressure, as I explained for the US, UK, for example. Right. Look at this. Look at this baseline. As long as this is high, forget it. You're just putting more pressure on the virus.
All right. I just want to remind our participants to upvote the questions. That's how I'm answering. That's how I'm asking them. So the questions that get the most upvoted are the ones that will show up on top as the ones that you guys are most interested in. So upvote those questions so we get them asked. This one is from Anonymous. I live in the most vaccinated county in the US. Over 93% are vaccinated. We have very low case rates and hospitalizations. Not sure if the disease is still circulating. What would you expect to see this winter illness-wise in such a highly vaccinated community, and for the vaccinated as well as for those who are unvaccinated in that community?
Well, much depends with regard to when is what going to happen. Much depends, as I was saying, on the speed of vaccination. You can imagine if you vaccinate very, very aggressively, and the virus becomes all of a sudden under tremendous pressure. If it wants to survive, there is only one way, that is immune escape, right? So it's not, people look very often at the vaccine coverage rate. High vaccine coverage rate is something going to happen there. It's essentially right now the first countries where we will see problems in terms of increased resistance to neutralizing antibodies will be in the countries or in the regions where the vaccination campaigns proceeded very, very aggressively. So it is clear that all countries will follow. I compare this with trains, all different trains. If you look at all different countries, regions, counties, etc., you will see that the features of the pandemic are still very, very different. But as we know, and that these are not my words, you can find this in several publications of molecular epidemiologists. We see that there is converging evolution of the mutations towards particular mutations in the spike protein. So as those mutations that are the reflection of increased immune pressure of the population, these are their words, not mine, or the reflection of increased immune pressure in the population. So you can imagine that the more these mutations are going to converge, the more all these strains will start to converge as mass vaccination continues and proceeds towards the same end station. And the end station inevitably will be resistance to the vaccine. So when is this going to happen? Of course, winter will promote this because you have, of course, more contacts indoors, etc. But there is one important thing I would like to say as well, that you will, the more the virus becomes infectious, the less you will see the impact of, I would say, social distancing, etc. Because when the virus becomes so infectious, I mean, a number of infection prevention measures have barely any weight anymore because the virus is so infectious, right? So what is now predominantly determining the evolution of the virus is, first of all, the immune pressure in the population and the level of infectiousness of the virus. So what will happen in winter in that particular region, I don't know. But is the virus still circulating? Oh yes, definitely. So that is the big problem. And when I hear experts saying, oh, this pandemic is going to burn out and it's going to degrade into a common cold, I just cannot believe it. Why? Well, what are we seeing right now? We are seeing that to some extent, the vaccines are still effective. I mean, I'm the first to say that do they still protect against severe disease, etc., and to some extent against disease? Yes. When we see that the vaccine efficacy is diminishing, it's very often because the immunity in the unvaccinated is increasing. That was what I explained before. So the difference with the placebo becomes less, so to say. But so why do people think it's going to die out? First of all, the vaccines still have certainly an effect, especially on disease. Secondly, we have more and more young people who are getting the disease and who are better protected. And it's rather rare that they get very severe disease and that they die. So we have mild to moderate disease predominantly in younger age groups. And in the vaccinated, we still have also protection against severe disease. So then people think, wow, this is going to die out. But this has, of course, nothing to do with, this is an artificial effect of the vaccine. It's not because a natural pandemic dies out spontaneously. When that happens, this is due to herd immunity. There is no other way a pandemic can burn out other than through herd immunity. Here, we don't have herd immunity. The vaccines don't do this. It's a kind of an artifactual impression that people get because the vaccines are still mitigating the disease. And in the non-vaccinated, we have mitigated disease because it's essentially younger age groups that get a disease. So the virus is still very much circulating. Remember when Israel was, this summer, they were claiming they got rid of the pandemic and they would open up society again, etc. For weeks and weeks, the infection rate was very low, almost close to the baseline, and then it got back, in a very aggressive way. We got again a huge wave. So that is definitely what's going to happen in other countries as well. But I cannot say exactly when this will happen because it depends on many factors, of course. It depends on how prominent is the Delta variant, what is the composition of the population, how aggressively were the mass vaccination campaigns conducted, etc. A number of parameters.
All right. Reminder, guys, keep upvoting those questions. We have 75 questions, so and limited time, I want to try to ask the ones that you guys are most interested in. The next one, Dr. Van den Bosch, there are more hospitalizations and deaths in the last several weeks compared to the same time period in 2020 when no one was vaccinated. Why is that?
Well, it's very simple. As I was saying, at the beginning of the pandemic, it was a different pandemic. It was a Wuhan strain. It was way less infectious. And the vast majority of people were simply naturally protected by their innate immune antibodies. So because we had in the meantime more infectious strains emerging, and again, I have explained this in several articles, how we came to these more infectious strains in the first place. We had them before the mass vaccination started. According to my opinion, it had to do with crowding in some areas, like in Brazil, like in South Africa, for example. And it could also have had to do with the excessive wearing of masks, right? Which is, of course, decreasing innate immunity. And if you decrease the innate immunity, you're going to give a competitive advantage to more infectious strains. So, but then, as we started mass vaccination, as I was saying, the big difference is that you then all of a sudden give an advantage to the more infectious strains, so their propagation would otherwise also increase, but not in such a fulminant way as it does right now, because the vast majority of the population becomes under immune pressure and gives this competitive advantage, and you have this enhanced propagation of more infectious strains. These more infectious strains are threatening the unvaccinated by the mechanism that I explained. A higher likelihood that they get hit by the virus during the time where they are sitting on short-lived antibodies that outcompete their innate immunity. So you're going to see an enhanced rate, of course, of infection and disease in younger people. And of course, the vaccinees then, to explain that part of the increase in the disease in the vaccinees, well, that is simply due to the fact that we are still vaccinating with the Wuhan strain, whereas the predominantly circulating viruses have completely changed. It's now, previously it was alpha, beta, gamma, now it's delta. So there as well, the vaccines are less effective because the antibodies do not match the antigen, the S protein of the circulating variant very well. So in both groups, we have an explanation. This pandemic has changed. It's another virus. It's another situation.
All right. Next question with lots of upvotes here from David. Assuming for the moment that the mass vaccination campaign will not be stopped anytime soon, can you please give your advice for how best individuals should behave at this point? Should they wear masks? Should they avoid crowds? What is your advice?
It will be so difficult to, and I fully understand this. it's again with this individual, right? I mean, at the benefit of themselves and the whole population, for the older age groups, well, let's say, look at the curves above 40, where the trained innate immunity has no much capacity to further develop, but is so important to maintain, because what you see right now is that people who don't have this trained immunity or whose trained immunity is undermined by a number of underlying diseases, unhealthy lifestyle, overweight, etc., etc. Those are the ones who are getting primarily the disease. So I can only advise to all the older age groups, I'm part of them and I'm doing it. Please get rid of all this fat. Take it really seriously. Nutrition, exercise, rest, maybe vitamins, but a healthy lifestyle. That is what is going to maintain your trained immunity, right? That is so important. That is critical. To the younger people, they have, as I was saying, what is very, very important right now is that we get we train their immunity. We cannot stop the mass vaccination. So all we can do is train their innate immunity. As I showed showing these curves, there is still huge capacity for them to train this innate immunity. And when they do so, this will automatically done by when they have more and more contacts. So closing schools, etc., not a good idea. So when they have more and more contacts, at least the unvaccinated, they will have a better trained innate immunity. They will start again to eliminate more and more virus. They will diminish the infection rate because their trained innate antibodies are less prone to be outcompeted by the specific antibodies that they will be continuously now sitting upon because they have these frequent contacts, and there is a high infectious variant that is circulating. So in fact, there is no way that through isolation or mask, etc., you will solve this problem. You will only delay this problem. So we need to go through this, right? And as I was saying, for the younger people, you see that the price that we are paying for it is relatively low. There's only few people who get disease or severe disease. And of course, yeah, the vaccinated people are to some extent still protected from severe disease. So, I mean, that is, so to say, for the time being, less of a problem. But when resistance will come, I mean, more than intervening in their in their behavior, it will be important to make early treatment available. So for the non-vaccinated, the older age groups, the best you can do, also for the purpose of the population, is train your innate immunity, get it well trained so that it can eliminate the virus, so that we can diminish infectious pressure. Same for the younger people, that will automatically happen because of the fact that they have this contacts that will train more and more and exploit the residual capacity they still have for their innate immunity. And for the vaccinees right now, well, I mean, there is no way you can avoid infection. And I mean, the virus is so infectious, it's circulating everywhere, and we have been relaxing infection prevention measures to a large extent. It will not be possible to bring them back with the same stringency. So we have to go through this, right? That is, yeah.
Dr. Van den Bosch, we're 90 minutes in. I just want to stop here and ask you how you're doing We have 79 questions, and I really want to encourage
I'm
the
still
audience.
doing.
You're
I mean,
okay?
if this is if this is of benefit to people, I mean, for me, we can continue as long as you want. I mean, this is the truth about the pandemic that will come out. I mean, the truth will come out. It's just a matter of how long is it going to take and what price will be in the meantime be paying. But it is so critical. It is so crucial. Under no circumstances, really, under no circumstances, can we vaccinate the younger people and the children. And I know to some extent it's already happening. We must stop this. We must stop this with whatever means, because if we don't do this, we will end up in a situation where we will have the roles of the virus and the immune system turned upside down. So what I mean is that if we continue with what we are doing right now and vaccinate younger people and children, we will get to a situation where the virus is going to exert immune selection pressure on the host. That is the other way around. If people understand what I mean, the virus is going to exert immune selection pressure on the host. This will be a natural selection, simply.
Okay. I'm going to keep going here. I have my coffee, so we can keep going for a little bit longer here. Audience, please keep upvoting those questions. We now have 82 open questions. I want to try to get the most pressing ones asked. This one is from Anonymous. The spike protein has been detected in circulating exosomes greater than 4 months after vaccination. This implies very wide biodistribution, even systemic expression of spike protein, and we're now seeing less antibodies in breakthrough cases. Is it reasonable to assume that the vaccinated are becoming a high-risk group?
Well, yeah, this is again alluding, I would say, to the side effects. You know my opinion about this. I have not been dealing really with this because, for me, as I was saying, and it's not because it's my theory or it's my field of expertise, but the damage and the losses that I'm talking about at the population level or an order of magnitude is way higher than all these side effects together. So yeah, I know, of course, these things have not been studied properly. Spike is circulating now, to be very open. It's not because you are injecting a vaccine in a muscle that none of the components is going to get into the systemic circulation. I mean, that is not something that the vaccine manufacturers didn't know. They knew this. Every vaccinologist knows that whatever you inject in the muscle in terms of vaccine, part of it is going to get into the systemic circulation. But of course, I mean, it has not been analyzed. I think what kind of the way this S protein could interact with blood vessels and the pathogenesis about spike protein induced thrombosis, etc. Nor has it been studied, I guess, what is important, to what extent does this mRNA get into several distal organs and can then be expressed in those organs. That is, I think, a much more, even more important question, because then you get like several different sites in the body where the S protein could be synthesized. So, but are they at risk? Well, I mean, a number of adverse events, which is, I guess, disproportionately high, have been reported. But as always, the vast majority of people are still, after those injections, doing fine, which doesn't mean that it's not really alerting the disproportionately high number of adverse events that are reported, and where, of course, there is some reasonable, I think, very reasonable scientific rationale that points into the direction of the very spike protein. So I cannot go much more in detail because it's not really my field of expertise. And as I was saying, for me, yeah, there is absolutely no reason for people with a good innate immune system, and most healthy people do have this, to get vaccinated in the first place. I'm sorry to say this, but that is really what the science tells.
All right, next question with lots of upvotes here from David. Dear Dr. Vandenbosch, thank you so much for all you've done and are doing. I'd like to understand if there is a way to determine if a person has developed protective immunity from a previous infection. I know there are antibody and T cell tests available, but can you please tell me, do any of these tests provide a reliable measure of protective adaptive immunity?
Well, I would say it's rare that you hear me simplify things because they're simply complex, right? And that is my biggest anger. And I would say that the community and health officials talk about this as if things were very, very simple. But basically, if you got previous infection and you got the disease, then, and you recovered from the disease, then of course there are always exceptions, but in the vast majority of cases, you will develop antibodies, neutralizing antibodies. And you can then go crazy and try to get your antibodies measured all the time to see if your levels are still high or high enough, etc. I think this doesn't make any sense. Why? Well, if you got a disease, your immune system got thoroughly primed. I can tell you, it got to see the antigen, very, very often. A vaccination cannot do as well, basically. That is also the reason why we need to give a booster shot, because after the first shot, the immune system has still not seen the antigen well enough. But when you got a disease, you have gone through that process of the disease. I mean, your immune system got primed. I mean, it's the best priming ever. So then, even when your antibodies are disappearing in the blood, I mean, who cares? Why? Because you have memory. Your immune system will memorize that the infection. And as soon as you get infected again, in no time, you will recall your protective antibodies. Now, of course, this could maybe last 1 or 2 days, and maybe in the meantime, you will get a little bit ill but we should not be afraid. This is also an important message, I think, of illness. We should not be afraid of illness. We should be afraid of severe illness, of course, and death and hospitalization, things like that. But again, even if you don't have antibody, they can't measure the antibodies in your blood. I mean, that's not how the immune system works. The immune system doesn't need to produce all the time this high level of antibodies, because otherwise it wouldn't make sense to have memory. This memory, it just, it's standby. You see the pathogen comes in again, wow, your memory will be again activated. Your antibodies will be produced at high titers with a high affinity, will neutralize the virus again. That is why most likely you have long-lived immunity against this virus when you got properly primed. But again, I must say that if we are going to continue this mass vaccination, so you got, for example, infected today with the Delta, or I will say you got, for example, infected with the Beta variant, and we have continued this mass vaccination drive, more propagation of more infectious variants. All of a sudden, it's no longer the Beta that is dominating. Now it is the Delta variant that is dominating. Okay, but if you get infected, you will recall your previous antibodies from the Beta infection. And to what extent to what extent are those still going to be protective against the Delta, right? To some extent, yes, but there is a high likelihood that nevertheless you can get the disease. So see, that's the problem. We are completely disturbing this system where normally when you got the disease, you get protected even against a number of variants. Now we are pushing this propagation of more and more infectious variants at the extreme, so that even people who got previously infected by another variant are now at risk of not recognizing the next variant or not sufficiently recognizing the next variant that is coming, because it's all in accelerated speed. Normally the Delta would come in 50 years from now, right? And then your immune system has the capability of adapting, because it can, of course, recognize a diversified spectrum of different variants. But if they differ all of a sudden within a short time span too much, then there is a risk that the new variants will not be very well recognized, even by somebody who got really the disease and recovered from it.
All right. Just a reminder, we have 92 open questions. We're going to continue on here, but please continue to upvote those questions. The next one, Dr. Van den Bosch, this is from Rebecca Allen. Biochemist Rhonda Patrick on MedCram with Dr. Sewalt stated that antibody-dependent enhancement will not happen because this vaccine has been designed to not go from protein pre-fusion to post-fusion. Can you comment on this point that she makes that ADE will not happen with the current COVID vaccines? She also states that the messenger RNA cannot get into the nucleus of the cell, and even if it did, there is no reverse transcriptase and integrase enzyme to cause the messenger RNA to become DNA. She says only viruses do this. Can you comment on this?
Well, I have given my opinion on the ADE. These are very often people, you know, many of them brilliant actually in their field of expertise, but don't understand immunology. I'm saying that in every single situation where you allow the immune system to generate antibodies that do not recognize the antigen very well, and that is regardless of the design of your vaccine, right? So it's not specific for one or the other vaccine. Every single time you end up with this situation, you are at risk of having, I'm not saying it's going to happen, I'm not even saying it is an issue, but it is certainly of concern that you may develop AD. And as I was saying, unfortunately, because of the evolution of this pandemic and of the fact that I was just giving the example just a minute ago about somebody who got properly primed because he or she had the disease and the immune system and recovered from it, and nevertheless may now in a very exceptional situation have to deal with low affinity antibodies, because these antibodies that were against alpha or beta do maybe not recognize the Delta variant well enough. So that is a low affinity binding. And there is several different situations where you have this low affinity binding. If on top then the antibodies are declining, binding is even lower. And in every single of these situations, regardless, I would say completely regardless of the design of your vaccine, you should take this into account, I would say. Yeah.
All right. Keep upvoting those questions, guys. This next question is from Eva. Could it be possible for you to meet and join the Nobel Prize Luc Montagnier, to probably massacred that name, to join forces for all of us? After all, you both have been you both have similar arguments, and you are both from Europe. Luc?
Yeah, well, again, for me, it's, how should I say? I know that Luc has also these arguments, but for me, the arguments are not sufficient. You have to explain them. You have to explain them in a way that that your arguments can withstand criticism, that you have an answer to all the questions that are relevant to your theory, in a sense that I think as soon as you start leaving stones unturned, you are at risk of making huge mistakes. And I mean, with all my respect, of course, for Luc and for his support and everything, I mean, for me, this is not about just joining forces. It's really about raising awareness by explaining to the people. Remember, this is an experiment on people. What is happening, right? What is happening? Because some people have joined forces and were making immunological arguments that I knew were completely wrong. And I've been criticizing them for, I could have said, oh, they are on in my camp, we are not going to criticize, because the most important thing is that we join forces. Now, if we don't, there is only one thing that can save us. That's the truth. And the truth is the science. And if we don't get the science right, it's going to go against us, right? This is just going to further encourage the stakeholders of these campaigns to continue and to laugh about us, about several different interpretations of the science, etc., etc. So it's good, of course, to join forces, but we first of all have to agree and consolidate the scientific principles that can make us say with 200% conviction, mass vaccination is the worst thing ever against this virus, and doing this in the midst of a pandemic. It's a catastrophe, and the science, we need to agree on the science, and that's why I continue to invite people, especially those who are who are leading these campaigns, to have an open scientific debate, which so far is not taking place. And frankly speaking, I don't have much hope it will take place, and so that is why I think making people aware is now the only way to raise awareness in a way that hopefully we can still bring some change. So that's my answer.
Okay. This next question is from Adam. Dr. Gert, don't you think that health authorities know what they are doing and their goal is not actually to improve the people's health? We see massive censorship of scientists that express different points of view all around the world. This mass vaccination aggressive process looks like supporting the ongoing pandemic through never-ending infections among the vaccinated and unvaccinated people, which leads to new restrictions. Don't you think there is a hidden bottom to this action?
No. So, as I explained at the beginning of this webinar, for me, the single major shortcoming in this whole crisis is that health authorities and even experts do not understand the pandemic. They do not understand the evolutionary dynamics and the impact it has. It's very complex. It's an interaction between a virus and an immune system that is now to be looked at the level of the population, because it's only at the level of the population that you exert immune pressure on the virus. And it's only at the level of the viral population that you exert infectious pressure on the host. So that level, that dimension has been completely ignored. And hence people have simply thought, well, we have the vaccine efficacy in the studies, let's simply extrapolate this to the population, regardless of all these things, infectious pressure and immune pressure, etc. And so the impact of immune intervention, massive immune intervention, has been completely underestimated. And so has also the impact of the large-scale infection prevention measures. As I was saying, if you have children, young people running around with masks all the time, it's going to dramatically diminish. We were talking about training the innate immune system, right? That's not what masking is doing, for example. So on the other hand, I can tell you, if this is even so complex that I don't think anybody would be capable of designing a kind of virus and a kind of strategy that would lead to this kind of crisis and issue and problem. And especially since it is very, very clear that this will not simply be an ongoing story with now health officials, they think, or some people believe that, well, if this thing is not going to die out spontaneously, well, then at least, with one shot a year, we are good, or maybe two shots. What I'm saying is forget it. This will just make the whole thing worse. It will expedite things, and this will not continue. We will see the resistance. We will see what the impact is of this resistance. So it's not like this is a never-ending story. This is, if we don't do anything about this, if we don't stop the mass vaccination, if we don't intervene in a way that we can dramatically diminish the infectious pressure, this is going to have consequences that even the most ingenious vaccine designer or public health official could never ever predict. The complexity thereof is such that it is beyond what human beings can plan for, right? So no, but what is certainly happening right now is that everybody's hiding, and nobody is taking the responsibility. And what with regard to liability, and I can tell you, if you see these things happen, where all of a sudden now third booster, all of a sudden vaccinate the children, all of a sudden all this hatred of vaccinees against unvaccinated, etc., all this is purely a reflection of panic, right? Panic, because there is no objective anymore. The objective, and the only objective, is herd immunity. It's only herd immunity that can terminate the pandemic. All what we are doing is against herd immunity. I think I made myself sufficiently clear to explain that all our it's just avoiding herd immunity. So what is the objective? There is no objective anymore. If there is no objective, there is no strategy, of course, right? And all this panic and of course nobody is responsible in the end. I think WHO is still responsible, but instead of communicating and instead of recognizing certain shortcomings, etc., it seems like nobody dares to do that anymore. And the more time that goes by, the worse, of course, the situation, right? And I don't know what is how these people are going to react when we will literally see that things will become very, very bad and everybody can follow this. I'm always saying, if you look at regardless, whether you look at infection or whether you look at the protection against severe disease, but if you take very simple to do, you look at the vaccinees versus the non-vaccinated, and you do that in a stratified way. So you stratify, of course, per age, and you stratify, for example, for underlying diseases, you can stratify per country, and then you follow what is happening in each age group. You compare the rate, for example, of severe disease or of death in the vaccinees versus the non-vaccinated within the same age group, for example. And you will compare this in 6 months from now. I tell you, the vaccine efficacy will, of course, dramatically go down. You need to do this in a stratified way. Anyone can follow this. These tables are even published. This is the way to follow it. This is the way to see whether the predictions that I'm making come true, right? It's not like this is simply words. No, we can make predictions that are based on the interpretation of these immunological events and of the pandemic in general. And we can make these predictions very, very clear, and people can follow those, right? So that is the only way, I guess, to also make public health officials aware that we know what's going to come, we know what's going to happen. And if they don't react to this, and they continue hiding and ignoring and just looking at these curves as if they were at stock market following, I don't know, cryptocurrency or whatever, and just see the trends and just make it descriptive without interpreting the data, then and hence not doing anything, not doing what experts who really study this pandemic are recommending or advising, then, I mean, for me, unfortunately, there is no doubt that this will end in a catastrophe. As I'm not withdrawing any of the words that I used or any of the calls that I did almost back 1 year ago. If we take away the herd immunity, if we take away the defense, the innate immune defense of the youngsters and the kids, I mean, it's just going to end in a catastrophe.
Dr. Van den Bosch, I want to be respectful of your time. I want to check in again and see how you're doing. We're 2 hours in, and how are you doing?
Well, for me, Erin, this is a mission, right? It's not about me. It's about really getting out the message. It's honestly, I think this issue should now be the single most important issue ever for everyone, is to make sure we avoid at any price, with any means, the continued vaccination of children and youngsters, right? This, I know people don't realize, because people think about maybe side effects, they think about the freedom, they think about how can it be that I, as a parent, have no right to decide whether I get my kid vaccinated, and that is the anxiety that you see in the population, and people are, of course, this kind of revolutionary in several different countries, but it is unfortunately not about really being aware of what this really means in terms of how this pandemic is going to turn out if we don't turn the tide. So yeah, I mean,
okay, so a few
my
more questions.
My time is nothing against that. My time is nothing compared to that.
Okay, so we'll ask you a few more questions, and you guys keep upvoting those questions so I can get the most important ones asked that you want to know the answer to, and maybe we'll go for like another 30 minutes or so, and then hopefully you'll come back on, Dr. Van den Bosch. This has been very helpful. We're getting a lot of good feedback from our participants. The next question has 16 upvotes. It's from Patty, and it's a pretty easy one. Would you consider going on the Joe Rogan Experience? You would reach millions of people with your important message.
Well, again, I mean, every single forum where we can discuss the science, where we can raise awareness, and I'm desperate for people helping me to maybe simplify the message, because in contrast to what many people believe, probably based on very cheap and hollow messages that they hear on TV and on certain platforms, this is extremely complex. And I'm already incredibly simplifying things, but I still realize that it's still difficult for most people to understand. So to your question, or to the question, to the extent that any interview, webinar, podcast can help people to better understand what is going on and what is on stake here, and where it is discussed in a scientific way, and not in a program where in 10 minutes, right, you have to discuss what's going on. That is simply impossible. But to the extent that it can be explained in a way that is understandable, yes, of course, I'm open to all those things, because it's very, very clear that no single public health authority, no single expert, no single professor is going to give this type of explanations. First of all, in all modesty, because they're simply not capable, right? I'm certainly not, I've repeated this multiple times, I'm not a top virologist, I'm not a top immunologist, I'm not a top molecular biologist or whatever, but I consider myself as a puzzler guy. I'm striving to find solutions to problems. So I consider myself as a problem solver. That means that you have to be,
This next question is from an anonymous attendee. Will suppressed innate immunity in humans caused by mass vaccination ever return to full strength? And if not, will these people be vulnerable to any and all infections? Is this why you refer to the situation as it exists with mass vaccinations as catastrophic?
Yeah, the answer is pretty much yes, in a sense that you have to imagine if we get, well, it's not if, I mean, there is no way around this, and with the decreased or increased resistance of the virus to neutralizing antibodies, if that happens, we are still dealing with a situation where we have highly infectious strains circulating. So then we have, in fact, the combination of both. We have the challenge of the highly infectious strains, and that combined to resistance. So, as I was saying, I cannot imagine, really, I cannot imagine how somebody can not have the innate antibodies that could sterilize coronavirus suppressed when high affinity vaccinal antibodies are induced. And of course, because these highly infectious strains or the Delta variant continues to circulate, there is, of course, a high likelihood that these people get boosted all the time, simply in a natural way, because this virus will continue to circulate. And then they will, again, boost their antibody response. What else can I say? With antibodies that can no longer neutralize the virus, but that are still capable of suppressing the most precious arm that exists against this virus, which is innate immunity. And I think that has been proven, as I said, at the beginning of the pandemic, thanks to this highly precious arm, the vast majority of the population did not even notice that anything was going on. So yeah, but again, we need to intervene, and we need to do something about this. And I mean, if people think they can still avoid talking about early treatment, so be it, but it will be inevitable to put this on the priority list, on the very top of the priority list.
Okay, this next question is from Peter with lots of upvotes. If full immune escape occurs with antibodies largely remaining binding to the S protein, what aspect of the immune system remains to fight against the virus?
That's the question. That's indeed, that's indeed the question. I mean, all you can do, as I was saying, is treat these people. because then they will get the disease, right? Early treatment. And I'm not, this is not my field of expertise, but it just makes sense. And I'm telling you, my background is veterinary medicine. Even in veterinary medicine, this is even a strategy to immunize a herd, for example, in the longer term. You infect the animals, the herd, with the disease deliberately. You infect them with the pathogen. They get a disease, and then you treat them. You treat them, so you cure the disease. In the meantime, everybody has built lifelong adaptive immunity, right? So here, we don't need to do that because many people will automatically get the disease. But when you treat them early enough, I hope we can do this early enough, there is still a chance that these people will develop adaptive immunity, and that adaptive immunity will be directed against this resistant variant. So it will be optimal. And the resistant variant will not vary anymore because it has achieved its resistance, its endpoint, right? So that strategy could still be very, very effective. But other than that, I don't know what could be done. Yeah, you could still vaccinate with another vaccine that induces sterilizing immunity, but that we don't have yet. And I'm not supposed to talk about, or I'm at risk of being again criticized by fact checkers, but a vaccine that could really induce sterilizing immunity, a vaccine that, in other words, could eliminate virus infected cells at an early stage of the infection. So that means way before the old antibodies get recalled, a vaccine that could induce an immunity that recognizes at an early stage of the infection virus infected cells and that can kill those cells. That would be the absolute solution for everybody, because then this would not at all interfere with all the previous priming. It would come way before that is initiated, and this would basically mimic the kind of mechanism that is occurring in people who are asymptomatically infected. People who get asymptomatically infected, to some extent, these people will shed the virus, they have virus-infected cells, but there is now compelling evidence that those virus-infected cells are very, very rapidly killed by natural killer cells at a very early stage of the disease, even before these people develop symptoms. That's why they get asymptomatically infected, and the virus gets eliminated from the body even before the short-term antibodies start to peak. So that means that these short-term antibodies have definitely no role in the elimination of those virus-infected cells. But most likely, according to some publications, these are NK cells. So if you would have some kind of immune intervention that can mimic this, and where this immunity is durable, that would be the absolute hit. I mean, that would be the ideal world.
This next question is from David. What options do we have to make sure our immune systems are robust against the ensuing disaster?
Well, immune systems are robust, as I said. Young people, their immune system is robust enough. I showed in the graphs that they can deal with frequent contacts. They will, of course, get infected, but they have still huge capacity to train so that they can increasingly take control of the infection. And while they are doing this, they are not going to pay a big price, because the morbidity rate and certainly the mortality rate is very, very low. So with regard to older age groups, the best way to protect yourself is to work on your trained immunity. You have acquired trained immunity through antigen experience. but you can mess it up if you don't treat it very well, and this is due to all kinds of lifestyles that basically make your trained immunity much weaker. There is even a number of publications that show very clearly that there is a correlate between the level of innate protective immunity and your health status, right? Of course, there's always people who have these underlying diseases and who are, have diseases like diabetes and cardiovascular diseases, etc. Again, for those people, we need to make sure we have appropriate early treatment available, right? And that is basically what I can say for both age groups.
Okay, we'll go to around 2:30, so I'll get in a few more questions here that have been upvoted. This next question is from Peter. Does the present threat justify secluding from society for a period of time?
Lockdown. Or is that what? Or yeah, well, not lockdown, but people who would just isolate and
Isolate.
go somewhere else. Well, at some point they will need to come back, right?
What? Right.
Is that the question?
That is the question. I guess
the proposal people would go to an island and see what's happening and then come back when everything is right.
Yes.
As I was saying, there is, I can understand that people cannot understand this yet, right? But there is one silver bullet in this whole thing, and that is one has to understand that we can only solve this as a population. We can only solve this as a population. So if we achieve herd immunity, herd immunity means immunity from the herd for the herd, right? Then we can solve this. We cannot solve this problem by just, I'm going to protect myself. Okay, you're going to be protected for some time, right? You're not, it's like a little bit in, again, my background, veterinary medicine. If you are part of the herd, your individual protection is only possible because you're part of the herd. And if you get out of the herd and if you isolate, you're no longer protected because you're no longer part of the herd. That is also what the herd immunity is about. You're part of it, and you help to build that herd immunity. That's not philosophical or that it's not philanthropic. It's just the way this system works. It's all at a population level. You want to be protected? Well, you have to be part of this herd immunity to contribute by improved trained immunity, by, for example, essentially trained immunity. And as I was saying, for the younger people, they will automatically achieve or come to a stage where they fully exploit their capacity of innate immunity by increased training, because they have more contacts, they are more exposed, and they will substantially contribute to diminishing the infectious pressure in the population.
This next question from an anonymous attendee: what danger is posed to a child by being vaccinated when they have documented symptomatic COVID?
Well, of course, this is, I would say, not just applicable to child. So this is really the question: what happens if my interpretation is correct? You had a disease, a symptomatic disease. So you had symptoms, you recovered from the disease, and then you get vaccinated.
Yes.
So I would say there is. This is a little bit theoretical, because there are arguments to think, wow, this is good, because you got, in fact, a boost of an immunity that was very good. So naturally acquired antibodies are very potent, and if you can now boost them, it's even better. There is a caveat though. The first one is, we already talked about this, which is there's always a likelihood that you won't have take of the antigen because you got immunized, you got probably good antibodies, and not the antibodies will not necessarily be measured before you get vaccinated. And so because of those neutralizing antibodies, as a result of the recovery from natural disease, will neutralize the antigen in the vaccine. And when that happens, you have no vaccine take. So the other thing that may be theoretical, but I would take this into account, is that if you imagine that you get vaccinated with an antigen that contains spike protein, which is different from the spike protein from the virus you got naturally infected with, right? Then you may have a situation that when you inject this new antigen through the vaccine, that the natural antibodies that are still in your blood, essentially, especially the high affinity antibodies, will bind to that foreign spike, I would say. And the new spike that is injected is not the same as the one you build antibodies against through natural disease. So will they bind? Yes, but primarily the antibodies with the highest affinity will bind, because those have still a chance to recognize the spike in your from your vaccine. And the low affinity antibodies will not bind. So again, this could, I'm not saying it's theoretical, but having then those free floating low affinity antibodies still in your blood may again predispose to antigen dependent enhancement. Remember, every time you have a situation where you have low affinity antibodies that are available and you would be confronted with the virus, exposed to the virus, that situation is theoretically possible. So, but last to this question, why on earth would you take the risk of such events or even of potential side effects when you are perfectly protected through natural infection? Why on earth would you do that, right? My only fear or my only concern, which I previously mentioned, is if we continue like this and we speed up the aggressive dominance of more infectious variants, then we might ultimately be in a situation where even people who got previously naturally infected and have in fact a full-fledged antibody response, naturally acquired antibodies that can recognize a large diversity of variants, even these people might be in a situation where they would not recognize the very new variant that is now predominantly propagated, because the whole evolution of this virus gets tremendously speed up due to the high infectious pressure, immune pressure in the population. And so the difference between those new variants and the antibodies, I would say, that have been raised, may be simply too big for these antibodies to properly recognize the antigen. And then again, you get in a situation of low affinity, and theoretically could be, even those people could be predisposed to ADE, which in a natural pandemic is unthinkable of. It's just because the evolution gets tremendously speed up.
Right. So let's do two more questions here. This one, what will happen to those who do not want boosters from an immune perspective? Will their bodies resort to their innate immune system to fight the infection?
Well, as I was saying, the boost is not making a big difference. All the boost is doing is that for some time, you will have elevated levels of antibodies again. right? Your previous antibodies, especially with the boost that we are now using. So you will increase your previous antibody titers. And in the meantime, of course, you will have even more suppression of your innate immunity. But again, as long, and that is why I'm so insisting, the only solution to this pandemic is, of course, to stop this mass vaccination, but then to intervene massively to diminish the infectious pressure. Because even if you don't get the boost, because the highly infectious variant, the Delta, is predominantly circulating, the likelihood that you will get boosts anyway by the naturally circulating virus is very high, right? So you will get boosted anyway because the virus is simply nothing is preventing or is having an impact on the dominance of this Delta variant. So that is why I'm always saying everybody's talking about disease and, of course, being protected and severe disease and hospitalizations, etc. Nobody, well, of these health authorities seem to be worried about this uncontrolled propagation of highly infectious variants, which is the single biggest problem that we are now having in this pandemic. This is no longer the normal pandemic. This is the pandemic of a highly infectious variant. And without impact, having an impact on this, you will not have an impact on whether you take the booster or not. I mean, yeah, the booster could predispose you to even more side effects maybe. But in terms of, and this was the question, in terms of immunology, it is basically coming down to the same result, because even if you don't take the boost, you will be boosted again, because we don't have any impact on the dominant circulation of this Delta variant, unless we do something about this, of course.
All right, Dr. Vanden Bossche, I'm going to ask you one last question here, but before we go, I want to remind everybody that this webinar will be up on the trialsitenews.com website, and Dr. Vanden Bossche, his writings are also on Trial Site News, his op-eds. I encourage you to read them. And Doctor, this has been great, very informative, and I really want to thank you for your time and answering all of these questions. And I believe you'll be back next week. We plan to do a series of these, and I hope all you guys come back and definitely participate. It's been great. So this last question I'm going to ask is from Jim, and it is, why are resistant mutants selected in vaccinated groups and not in unvaccinated groups? Meaning, if unvaccinated get immunity from exposure, would there not be infectious variants selected in unvaccinated over time?
Wow, can you repeat the second part of that question? The second part.
Absolutely.
So yeah.
If unvaccinated get immunity from exposure, would there not be infectious variants selected in unvaccinated over time?
Well, if unvaccinated get exposed, there's two possibilities, right? They develop asymptomatic infection, or they develop symptomatic infection. If they develop asymptomatic infection, that means that their innate immunity, provided it's not compromised, of course, right? And I told you the situation where it can be compromised is when they get re-exposed very soon after the previous exposure. But let's assume their innate immunity is okay. They get exposed, they get asymptomatically infected. Because of their innate immunity, they are going to eliminate the virus regardless what variant that is. We can still have 2,000 other variants. The innate antibodies, the innate immunity will take care of whatever variant. And it does not discriminate against one or the other variant. So yes, in that situation, you have no immune selection pressure, right? In the other situation is you have an unvaccinated person who gets symptomatic disease. As a consequence of asymptomatic disease, this person will now develop full-fledged acquired immunity. The full-fledged acquired immunity is also capable, as I mentioned already a number of times, to recognize a very broad spectrum of several different variants. And it will, so to say, not favor one or the other, because it will recognize a very broad spectrum of those, provided it is full-fledged immunity, of course. So in both cases, there is no reason for this person to select or to discriminate against one or the other variant. This can only happen, of course. So see, that is something that is very important to understand. I think we should mention this. People have to realize that if you get infected and you develop symptoms, what are you going to do? You are going to isolate yourself. And you're going to be isolated for as long as the disease lasts, and then maybe still during the time where you recover from the disease. During that time, you build full-fledged acquired immunity, and you will only get back in society when your full-fledged immunity is optimal. You have built it while you had isolated, and then you come back and you're ready. You are ready to tackle these variants that are circulating because you have full-fledged immunity. If you now vaccinate somebody, when you vaccinate somebody, you're not going to tell people you have to isolate for 2 weeks till your antibodies have reached, high titers and have completely gone through the affinity maturation. These people, while they are still in the process of building their antibodies, are already getting, because they are just having contact with anybody else. And so while they are still in the process of building their antibodies, they are already exposed to the virus. And that is where even acquired immunity can be subject to immune escape or can induce immune escape because it is simply not full-fledged before it got exposed to the virus. So the virus will take advantage of this suboptimal immunity to select, it's in fact the immune system that will do this, to select variants that can overcome this partial, immature immunity. And if you have many people who are in that situation, because many people get vaccinated, that are building suboptimal immunity and that are already exposed to the virus, you will, even despite the fact that you have acquired immunity, you will drive immune escape. So that is the difference really between getting acquired immunity through vaccination during a pandemic, and getting acquired immunity during a pandemic, but as a consequence of natural disease, where you give your body the time to build this naturally acquired antibodies before you get back into the herd, I would say, and get re-exposed to the virus. So in both cases, if it is done properly, an unvaccinated person should build full-fledged immunity. But as I said, in case of the asymptomatic infection, this person should not be carrying antibodies that have been elicited as a consequence of previous asymptomatic infection, because these antibodies will suppress the innate antibodies. And by doing so, the innate antibodies will not be capable of eliminating the infection. That's what we saw in this graph, where you see all of a sudden these high gray columns in these younger age groups, right? This is due to the fact that the innate antibodies have been bypassed, couldn't do their job, because if they could have done their job, they would have dramatically reduced the infectious pressure as we have seen in the next graph, when this immune system got better and better trained, right?
All right, guys, we are going to wrap it up here. Thank you so much, Dr. Van den Bosch. That was very informative. You're going to be back doing a webinar, I believe, next week. And for all of our participants, thank you so much for participating. And if you go to the Trial Site News website, there's several other webinars that have been scheduled. I encourage you to sign up, and I really appreciate your participation today. Thanks, everyone. Thanks, Dr. Van den Bosch.
Yeah, thank you, Erin. This has not been easy to facilitate. I understand, but and I would like to conclude with saying that I know that I am taking very extreme positions here, but I want people to know that I'm 200% convinced of what I'm saying, and that I'm very much looking forward to having, in one way or the other, action taken against this mass vaccination, and especially the mass vaccination of the younger age groups. Thanks so much, Erin.
Absolutely. Anytime. You're always welcome on this platform.